I'd just like to say that in the light of this constraint looking like this, sometimes they ask you a question like this and they'll say to you, which constraint made no difference to the actual question? And then you could safely answer that this one, that blue line I've put in there, is actually not affecting the feasible region in any way. So sometimes they do ask that. I personally think it's probably just a hearing thing that I've perhaps written down a number incorrectly, but we might as well just adjust the question too because the end product will be right.
Okay,
Right. Karabo, you back with me?
Yes, ma'am.
Good, good, good. So now we are looking at the gradient of minus 4/5. Now, what are we going to do? We're going to draw a search line. Now, to draw the search line, we need to go to our line and we need to plot in some points. So before we do that, let's talk about how we're going to represent that gradient. Now, we know it's the change in y over the change in x. So what's it telling me to do, Karabo?
Sorry, ma'am.
Okay, -4 is telling me I must go.
And we must go 4 to the left.
And 5 to the?
Right.
Right. Yes, good girl. So now, it doesn't matter what 4. It could be 40 and 50. It could be anything. So I can take 4 divisions. So if I do that, it'll be 1, 2, 3, 4. So we would go from there. And 5 across would bring me to 150, 180, at about there.
Okay, ma'am.
Okay, so now what I'm going to do is I'm going to put that search line in.
Okay.
Now, it doesn't matter that the search line's at the top of the region.
Okay, ma'am.
No, it doesn't. It really doesn't make a difference at all. We're very
okay.
welcome to have it anywhere on the drawing. But what I would normally do at this stage is I would mark in on it, search line. Because, of course, you can't do what I'm about to do. So I'm going to put in a line and I'm going to mark in search line. So let's just do that. Let's take a blue line on top of that. And I'm going to write on here, search line.
Okay, ma'am.
Okay, that just tells them that that's my line that I'm using to search the feasible region. So I pick it up.
Okay.
Assuming it'll let me pick it up, that is. It's not letting me be nice or kind to me at the moment at all. No, it's a move the word. So let me just mind that out the way because that's not letting me pick up. Ah, there you go. So I move it down to the start. And now I know that if I want to maximize, I must search the area to the last point of contact. If I was minimizing, what would I look for, Karabo?
It was going at the top.
The first time it touched, hey? So let's have a look. As I slide up, that would be the minimum. But I'm not interested in that. I want the maximum. So I carry on sliding, and I can see that it's actually going to happen over here. So I'm just going to go and highlight that point. Now, of course, I haven't drawn a very nice drawing. I've drawn a very freehand sketch. So I would have to work that point out by using simultaneous equations. But of course, if you had graph paper, you could just read that solution off. So let's work it out by simultaneous and we'll go from there. Right, simultaneously, I'm looking for the solution of x equals 60 with this black line, which was the first one we drew, which was 4x plus 5y equals 400. 4x plus 5y
equals 400.
Equals 400, correct. So if I was going to solve that simultaneously, that's equation 1 and equation 2, I would substitute equation 1 in 2. So in other words, wherever there's an x, I would put 60. So it's plus 4 times 60 equals 400. Right, that means that 5y plus 240 equals 400. Which means 5y is equal to, and I transpose, so what would I get?
You'd get
160, hey? I'll be kind. I know the calculator's not standing by, so we'll just do it like that. Divide by 5, divide by 5. So y is equal to 32. So now I've got the y value. I know what the x value is, so I know my coordinate A is 60, 32.
Okay, ma'am.
So that's where it would maximize. And then if I wanted to actually give the profit, if they said, what is the profit? I don't think they did ask you that, but since we're here, let's do it. The profit would be, according to this, 200 times 60 plus 250 times 32. And of course, we could just pull up our calculator and put that in. So we would say 200 times 60 plus 250 times 32. Right, that would give me a nice profit of 20,000.
Yes, it gives a profit of 20,000.
Good. Now, the next part of the question, and this is the one that I was particularly interested in when you phoned in. And that is
Okay.
the search line changes. And they then ask you, will it still be at the same place that we maximize? Well, the only way to find that out is to put up your new profit equation. So let's get
Okay.
some space over there. The profit equation they give you is 180x
180x.
plus 240y. So what's the first thing we do, Karabo?
Don't you solve and change the equation if I'm not mistaken?
We do. We change the equation round so that y is the subject. So let's do that. So we leave the 240y behind, and we bring this minus 180x this side plus the p. Then we don't want this 240, so what are we going to do with that?
We isolate it.
We're going to divide this side by it and everything this side by it. Now, all we are interested in is the gradient, which is that thing there. So the gradient of that will be minus 180 over 240. Now, if we're going to simplify that, do you agree with me? We would divide by, looks like 60 would be good, so we get minus 3 over 4.
Oh, yes.
Now, you can see that your gradient has changed, but the question is, has it changed enough to change where we are going to maximize? So what we have to do is we have to go to the drawing and draw a new search line, which we're going to do right now. So let's go and do it. We want the gradient of this new search line to be minus 3/4. So let's just get rid of the bits and pieces we don't want. So let's cut it, and let's cut it and get it out of the way, and then let's put in the new search line. Right, so the new search line, we're going to use the coordinate. We're going to go minus 3 down. So from 9, I'm going to start here. I'm going to go down 3, and then I'm going to go across 4. So that's going to bring me here. So that looks like it's that blue line, okay, which is great. So we can just use the blue line, which is super. Right, let's pick it up. And we want to know if it maximizes at the same place. So right, as I lift it up, oops, don't lift that one up, lift this one up. You can see that would be the minimum, and that's not what we want. And along we go, and we'd see that that would not be the maximum anymore, but rather this one down here would be. So in actual fact, the point changes to this point here, which we have worked out already, haven't we? It's actually this point over here, 100, 0. So no, it's the answer to this question, let's just get ourselves some space, is no. This search line requires 100 type N's and 0 type S's. By the way, while we're here, there's one thing I haven't done on the drawing, which was very evil of me, so let's just quickly do it. What have I not done, Karabo?
I'm not sure, ma'am.
So it's a silly thing. I forgot to label my axes. Okay, so over here I should have type S, and over here I should have type N. Okay, it's not a big thing, but it is important in terms of your exams. You want them to be able to know that, otherwise they take off a mark, and that would be really tragic to lose a mark for something like that. So great, so that's your question. I hope that answered it. Is there any other question here that you'd like me to address, Karabo?
No, ma'am, thank you very much for helping me.
It's a pleasure, my love. Phone in again and give us some more of your questions. We'll help you with pleasure. Thank you for phoning in. Bye-bye, Karabo.
Bye.
Speak to you soon. Bye.